Okay, so we're going to look at time series today. So time series is still bivariate data, and it's actually, a time series is very similar to a scatter plot in terms of you'll have two numerical variables, and the only thing is that the explanatory variable will be a time thing, and whatever they're looking at over here for the response will also be a numerical. So you get your scatter plot, and what happens, the difference with the time series is you just actually connect the dots. The lines are drawn in between the dots. Okay, so often when you do the time series, so instead of, they might not write, so say, for example, they wanted to start back in 1931 and they go all the way up to now or something, they might not call the variable 1931. They might say the first year they recorded, so then 1932 would be a number 2. So that's how they, sometimes you might get it's called a time code. So they'll say maybe number 1 represents, depending where they started their investigation, they might say number 1 represents 1980 and then so on, or something like that. So not all the time we can put in the years. Like we might be able to put in 1931 as the year, that's fine, but sometimes we will use a time code. So the first thing when we get these time series is, we always want to do some analysis of what the data is showing us. So the first thing is generally we look at trends. So if you look at this time series down here, you can see say this was over many years, it does randomly go up and down. But what we like to say overall, if we look at the beginning to the end, you can see that it is on its way up. It's moving up. So we'd say an upward trend. So this one here you'd say an upward trend. If I was describing this time series, I'd say here that it's an upward trend with some random variation, because it is going up and down, or random fluctuation, whichever word you want to use. So it's going up and down, but overall it's moving up. And so with this second one, you can see overall it's moving down. It does have some random fluctuation, but overall it's moving down. So that's a trend. So you might have something like this where you've got a couple of trends within the graph. So between 1940 and 1960, we saw an upward trend. We might say after 1960, we saw a downward trend. So if you have a look, this is birth rates. I'm not sure which country, but obviously around you had an upward trend of birth rates, higher birth rates, around the end of the 1960s is the beginning of the Great Depression, so therefore birth rates reduced and went down. And then, so things like that you might have, so they'll look at that, they'll say, what happened here, what's the trend, and someone else will go investigate that. All right, now another thing that can happen that we may see when we're looking at time series is we may see seasonal variation. So what that means is within a year, you see the same thing happening all the time. So if you have a look here, can you see that on the June, even though it's moving up and down, June seems to be be the drop. So that is seasonal. When something's happening within the year, seasonal does not mean autumn, winter, summer, spring, just means that within a year, we see a same pattern happening, okay? That's seasonal. So if you look here, or you could have another thing called cyclic pattern. Now, just write the word up there, because some people, they do use the word cyclic, and some kids get confused and say, what's that? So can you see, this is not happening within a year. We're seeing a drop every 10 years. Roughly, yeah? So every 10 years. So when it's outside, but we see this thing, we call it cyclic. So if it's happening within a year, within a small time period, that's when we say seasonal. if it's at the same time. Here, when it's over a great amount of years, we might say, describe it as being cyclic, a cyclic pattern happening there. All right. And as I said, nearly all time series are going to have this. So all time series will have random variation or fluctuation. So when you're asked to describe the time series, you're pretty much safe bet always is definitely writing that this is happening and whether some of the other things are happening. All right, so let's have a look at this exam question. It says, consider the time series plot. So if you have a look down here, just take note that it's in month number. So here, really, we've got the end of a year, there's some years there. But can you see, because we are dropping every year within the year, we would probably say that's seasonal, yeah? Because it's within a year that you're seeing the same thing. So there's definitely random fluctuation or variation. So if we go through the multi-choice, we're going to say irregular fluctuations only. No, because we can see a little bit of seasonality. So we might say that it's seasonality. Now, can you see they're saying seasonality with an increasing trend? So what that means is, if you would see how we can see that the drop is happening every year, but see how it's pretty much staying around the same spot. Yeah, if I had, for example, a time series that, say this is, I'm going up in months again. So say I saw this time series doing that. Can you see that it's dropping every year? So it has seasonality, but can you see that it's going up? So that would also be with upward trend. Okay, but this one's not doing that. So this one is just seasonality with irregular fluctuations. So this one is C. Okay, so these are the type of questions you're going to get. Okay, so let's have a look at this one. It says the wind speed at a city location is measured throughout the day. The time series is shown below with the maximum wind speed per hour over a 3-week period. The time series is best described as, so what you need, so seasonality, this would be a case of seasonality because it's happening in a short period of time, not over many years. So we could see seasonality, but if you have a look, you go 1, 2, 3, 4, 5, 6, 7, yeah? And so we saw a drop between 2 and 3. If I was doing the next 7 and I go 1, 2, 3, 4, 5, 6, 7, see how it may look like it's dropping in the same spot, but it's not, is it? Because if you look here, we saw it sort of drop there, but then if you go between 2 and 3 here, it was sort of different. And then you look at this one's 1, 2, the drops in the 1, 2. So are they in the same parts of the week? No. So there's no seasonality here. So this one is just irregular fluctuations. We may say, oh, is it going up over a period? I don't think so. We've just stopped it at day 1. And day 1, so when we can look across here, they're not really moving. So we don't have no upward trend there. And we're going to just say it is irregular fluctuation only. Okay? All right. In a little while, you'll do 6A, but we're going to move on. Very easy, this part of time series. Okay. All right, so what we have now when we're doing these time series is that we've seen that we get this random fluctuation, but we can see some things that are regularly happening maybe in seasonality. So what we like to do is we try to do some techniques that smooth it. And if the first one, there's a couple of methods, and the first one we're going to look at is the mean smoothing. So just be careful. So mean is when remember the mean is like the average. So if you have a look, it depends what we're doing. So if we saw something happening, like say like 3 things happening within a year, we would probably try to smooth it using a 3 mean. If we saw something happening maybe daily or something, the days are all different, we might do a 5 mean smoothing. But anyway, let's look at how we do that. So what we have here, this was the original data of number of births. So they're doing births within the year, okay, of some place. So if we're going to do 3 mean smoothing, the first smooth data point, so just to be clear, so you would have had a time series like this, so births and then the time, and so then you've got January, February, and so on. So the first one would have been 10, or there's a dot on 10 and so on. So that's that list of data there. So if we want to smooth the data, what we do if we're doing 3 mean smoothing is we take the first 3 numbers and we find the mean of them. So how do you find the mean? You add them up and you divide by 3. So the first smooth data point, and it will happen on February because you put it in the middle of it. If you look at finding this second one, if I was going to find the next smooth point, I would take the next 3, so February, March, and April, and you can see they've done that there, and they've divided by 3, and that would be the next smooth point. So you could end up eventually smoothing the whole time series, and so say your original one looked, I'm just making this up, looked like this, your smoothed one will look a bit more smooth. It takes away those big jaggeds, okay, and it smooths the trend off a bit. What they often do though in an exam is they just ask you to do one off, and they might say, can you do the smooth data point for September? So if you've got to do the 3 mean smooth data point for September, what you do is you go, all right, I definitely need the September number, and I need 1 before and 1 after. And you can see what that they've done that. And this is the smooth data for September. Okay, 3 mean. Now, obviously 5 mean, what do you think you need to do? You add up 5. So if they ask me, say for example, they said, find the 5 mean smoothing data point for October, what I'm going to do is take October's number, and I need 5, so do 2 after it and 2 below it, and you'll be able to see that done there. Oh, sorry, done here. Okay, and that's October. So it's pretty easy. If you've got to do the whole thing, it takes a little bit longer, but that's practicing. But in an exam, you'll just get one off. So here we say moving the means of groups of 3 or 5 are most common, but you can be asked, and we have seen it in recent years, that they can ask for a 7, or even, I think there was one where they said 9. So you just add them all up around it, and then if you had 9, you'd have 4 below it, 4 above it, and the 9th one in the middle, if you had to find one off. All right. Now, that's when we have odd numbers. It is pretty easy. When we have an even number, so we can get asked to do mean smoothing with even numbers, this is where you have to add an extra step in. Sorry, I'm just going to move up. So the extra step is you have to center it. So this centering is when you have an even number. So if you have a look here, when they're working out 4 mean, what they've done is they've taken the first 4 here, they added them up, divided by 4, and they got an answer. The next time, then they took the next 4, which was those, they added them up, they divided by 4, and they got an answer. So then what you have to do is you then have to center it. And what you do when you center it is you take those 2 answers and you add them together and you divide by 2, and you end up with your 4 mean smoothing with centering for that first spot. And it's going to be, your first one that you couldn't possibly do if you had the years would be March. So when you do 4 mean smoothing, you lose the first 2, and your first data point would be on March. Back here on the 3, when you have 3 mean smoothing, you lose the first and the last data point. Last data point is lost. And when you have 5, you would lose the first 2 and the last 2 because you can't possibly do it. So once again, they'll ask you just to do a one-off. So say July, they go to me, do the 4 mean smoothing for July. So what I do is I know I've got to do one scenario where I take July and I'll do 2 below it and 1 above it. So I do that one, and if you have a look, that's here. And then then my other scenario for July would be where I just go 1 above it and 2 below it. And that one is, so this one was the circle scenario, and this is the square scenario, and you can see we've added them together, and this was your answer. So this is your July 4 mean smoothing data with centering. So they will always have with centering. You've got to center it when it's even numbers. Okay, so let's go and do a 2 mean, because that's an even number, and we'll do it together, and you can write it on the sheet so that you can see. So first of all, yeah. Okay, so let's do the the 2 mean smoothing with centering. So first of all, you take the first 2, so it'll be 10 plus 12 divided by 2, and you would get 11. Then my next 2 would be 12 plus 6 divided by 2, which equals 9. Okay, and then the centering bit will be when you add those 2, so it'll be 11 plus 9 divided by 2, which will be 10. So this 10 is the first smooth data, and it actually would fall on February, okay, because you lose the first one in this instant. Okay, then my next one, I'd have 6 plus 5 divided by 2, so that would be 5.5. And then my next smooth data would be the 9 plus the 5.5 divided by 2, which equals, what's that, 7.25, is that correct? 14.5, yeah? And that would be March's, okay? And then I'd keep going. Does that make sense? Yeah? So just to show you, because it's hard, generally they only give you one off. So if I go straight down, I'm going to show you straight down to October, if I had to do October's 2 mean. So the first scenario would be I go 1 above it, so it'd be 9 plus 10 divided by 2, which is 9.5, and then I do 1 below it, so 10 plus 8 divided by 2, which is 9. Then I'd add these 2 together, divided by 2, which would be 9.25, and that would be October's smooth data point. You can do them in the calculator. I'm just doing it in my head, but you're fine to do it in the calculator.